I'm going to give you a brief rundown of contour surveying. This lecture was actually prepared by Kumar at Polytechnic College, but the notes are good, and so I've edited a few of the slides out to just get a few of the basics to talk about. Keep in mind that when we're developing a contour map, they're just imaginary lines on the ground that are going to join points of equal elevation. So when we're using contour maps, it gives us an idea of the altitude of the surface features as well as their relative positions in both the plan and section of the map. Contour survey is carried out at a starting point that is usually a benchmark of some kind. It could be a road, canal, dam. Keep in mind a few basic points about surveying when you're doing contour maps. All points in a contour map or contour lines have the same elevation. The flat ground is indicated where there is no contour lines, and so they're either widely spaced at that point. The steeper areas are where the lines are closer together. A uniform slope is indicated when the contour lines are uniformly spaced. Here's a good way to think of it. So this gives you a side view and actual contour view. You can see the same thing if it is a depression or a valley. It'd be the same type of area where the lines are closer together, the slope is steeper, and that has a direct implication for the kind of work we do, because we're usually very interested in where things are going to run off. Contour lines cross ridge or valleys at right angles. If the higher values are inside the bend or loop, it's an indication that it's a ridge. A valley at 50-foot elevation all along this line versus 100-foot elevation. So depending upon what our scale is, we would go from 100 foot of elevation here down to 50. Contours cannot end anywhere, but they close on themselves either within or outside the limits of the map, and you can see what would happen if you had a steep cliff, or in fact maybe an overhanging cliff. Might look something like this on the map. Contour lines are never run into one another except in the case of that vertical cliff, and then it's impossible to really tell without some kind of side view exactly what's going on here. So there's a couple of different methods of doing contour maps. There's the direct method and the indirect method. With the direct method, you actually need to find all the points that are along this survey that are at 50 feet or 48 feet or 46 feet, depending upon what the scale is that we're looking at on the map. Most of the time, we're going to go with an indirect method where we're going to locate points on some kind of grid, and then we're going to get their positions and we're going to plot them out. So this kind of survey is often called a square method, where the whole area is divided into a number of squares, and it depends on the scale we're using. We could do 50-foot squares, 25-foot squares, or 100-foot squares. Here's an example of one where we've got using the squares. And so what we would do with this particular plot is we would come in and we'd set flags or stakes at these different intervals, whatever the intervals happen to be, and then we would get the readings at these intersection points, and that would allow us then to go in and connect the areas of equal elevation by drawing our contour lines after we're done. So we know that the 98 would be running between here. We also know that the 97 would be running in here. So we can either scale it to determine where that line's going to go exactly, or we can estimate it. And for a lot of the work that we would do with grass waterways or with just watershed areas, we might just want to estimate that. It depends on how accurate our survey needs to be. Here's another example, 97.8. Now, if you have something like this, where you have a hill, it might be advantageous to make a note of that while you're doing it, because when you get home you might not realize you would have a 98 here, and you might be trying to draw the 98 from here to some point between here, and we can't tell really if it has some kind of valley or swale or something like that unless you have kind of a good indication of what's going on there. So the important points within the squares may be taken separately. So it doesn't have to be on a corner. It can be somewhere else if we see something of interest and we want to be able to identify it, such as a depression or a road or something else that's going through a real map. So here's a Google image showing you what an area would look like. But the thing is, it's a little bit hard to tell. So is this higher up here or is this lower over here? It's just a little bit difficult to kind of see where the lay of the land is that we're interested in. But if we're interested in maybe this watershed in through here or something along in this area, then it would be nice to have a contour map to see exactly what we're looking at without all the distraction of the landscape. And so here's an example of that, where you actually have the contour lines, and this is at a scale where it's maybe a little bit hard to read the specific numbers, but you can get a general idea, and you can certainly get a much better idea for the lay of the land with a contour map that's drawn in such as this. And this is, of course, a much larger scale than we would be doing for the small watershed projects we might work on, but it gives you an idea of where to go with this information. Hope that was helpful.